So first of all, let me say I am so happy to be with you today. I like the Python African community a lot. I believe it's, I was telling Marlene on Wednesday, I think it's a very alive community. I like this. At the same time, I'm a bit sad because I'm not really there. I'm not there with you, right? Wherever you are. So I just want to say, okay, it's okay to have these technologies, but the human touch is invaluable. Take this, coronavirus. Leaving aside this, let's go on with today's topic, the clean architectures. Today, I will talk about clean architectures in Python, or more in general, clean architectures. And the subtitle of this presentation is A Tale of Durability, Utility, and Beauty. And I hope it will be clear in minutes why I gave this subtitle to the presentation. Very quickly about me, I am a software engineer and a blogger. I currently work in London, UK. I used to blog on the Digital Cat Online. As you can see, I'm reachable on Twitter. I am a cat person, and I want to say it because there is one thing I value in cats, aside from the fact that they are very beautiful. They are curious. They are full of curiosity. They want to know. You know, if you put something new in a room, the cat goes immediately to see what it is. And I value this, and I want to encourage you to be curious with life in general, in software development as well. Don't be, you know, don't be satisfied with just the surface. Don't be shallow. Go deep into things that you like, because this is where you can discover a path for you, I believe. Okay, so enough about me. About clean architectures, the first question I have today, I want to answer, try and answer, is what is the definition of architecture? I have here in the slides the beautiful Cathedral of Florence, and I went there many times, and I was like, oh, this is amazing, this is beautiful, right? What a beautiful architecture, what a beautiful building. And so my question was, why do we use this word architecture in software? What is architecture? And Vitruvius, who was a Roman architect, he was born around the 70 BC, so more than 2000 years ago. And he wrote this book called De Architectura, which means about architecture, in which it says many things. And one of the important things he left us was this description of a building. He says a building should have three features: firmitas, utilitas, and venustas. And they can be translated in English into durability, utility, and beauty. Hence the subtitle of the talk. Durability might be translated as strength, but I like durability more because I like the idea of something that lasts, you know, that stands the test of time. Think about your software now, just a second. How many times is it durable, useful, and beautiful at the same time? Not many, as for me. I give you an example of what I mean with durability. The Unix operating system was conceived around the 70s. So it's more than 40 years. It's almost 50 now. And now, 50 years after someone came up with Unix system in a world that was so different from ours. You know, they didn't have mobile phones, they didn't have laptops. It was so different. But 50 years after that, we are still using, I am giving you this presentation on a Linux system, and many of you are probably using an Apple Mac, which are both derived from Unix. This is what I mean with durability. 50 years, guys, not 50 days, which is the usual span of my software, right? Okay, so durability, utility, and beauty. When I went a bit deeper into software architecture, so not moving away from the buildings, I found this interesting definition in the dictionary. because I'm not a native speaker, so I go to the dictionary many times to see what things are. And the dictionary says the art and science in which the components of a computer system are organized and integrated. So the first thing I want to point out is art and science. Now, how many of you, coders, programmers, consider themselves artists and scientists? It's amazing. I mean, we have to stop considering ourselves coders, and we have to start thinking at ourselves as artists and scientists. This is what we are. And architecture is where the art and science of all of these meet, okay? And they meet doing this in deciding how components of a computer system are organized and integrated. Organization is about where components are. So where the components of your hardware or software are located in your system. And integration is about how data flows between them. So what happens when you log in into the system? What happens when you run that function? What happens, and so on. In the background of this slide, I put part of the board of the Amiga system, which is an impressive example of art and science put together. So yeah, this is what we aim to do. The second question I have is, do we need architecture? And let me say this, many people, when they see this, this slide, believe that I chose this picture because it's not very impressive, right? On the contrary, I chose it because I was struck by this. So when I saw the picture, I don't know where this was taken, but when I saw the picture, I thought, look at this. The person or the people who built this house didn't have the best materials, right? And probably they didn't have the best science at hand, because it's arguably a bit leaning on the side. It's not perfect, but they wanted this to be beautiful. They wanted this to be durable. Because look, this has a roof, this has a door. I mean, it's just a lump of stuff thrown there. It's a house, right? So what I want to tell you is this: why do we need the architecture in life and in software engineering? Because we need it. Because this is what we need as human beings. We need things to be well done. And you are more satisfied when you do something well than when you just throw there a bunch of code that doesn't live for many days, okay? More technically, we need architecture because if we don't decide for an architecture, if we don't think about it and take action towards a specific architecture, something else or someone else will decide for us. And many times, requirements decided for us, because we just react to requirements. You know clients, right? The requirements change every second, and you just react to them, patching your system and not getting anywhere. So requirements dictate an architecture, or the framework dictates an architecture. I'm pretty sure there are many Django users among you, which Django is an impressive framework. I like it a lot, but Django pushes for a specific architecture. I'm saying something more about this later, maybe. But what I want to say is that if you don't understand this, if you don't learn and understand the Django architecture, you just leave everything to the framework. And this is not good, because in the end, you are not in control anymore. This is what I wanted to say. Okay, moving on. The software architectures and design, software architecture and design is something that has been studied from the very beginning of the computer science journey in the world. These are some of the books that I found very useful for my for my career, for my understanding of the architecture. Note of warning, these are door stoppers. Sometimes they're very thick, and you have to study these books. They are not just, you can't read them while you are suntanning on the beach. So if you don't want to commit to these books, I understand. And I have two books to point out, so Design Patterns and Enterprise Integration Patterns. Read the introduction, just the introduction to those books. Because both introductions are very narrative, they are not too technical, okay? They are lightweight somehow, but they give you an impressive overview of what happens when you design a system. In particular, Design Patterns, it was written many years ago, 94. And these guys were discussing how to design an object-oriented system, like a clone of like a word, word processing software. And it's impressive how they keep putting requirements and discussing them and trying to find the best overall architecture for them. Okay. Today, in this presentation, I will give you an example of software architecture in Python, a very simple example. Unfortunately, I don't have that much time, and I don't want to bore you to death. So I'm being shallow today. So the next thing I want to discuss, is what is the meaning of clean. So I try to define architecture. Now let's go on with clean, because we are discussing the clean architecture. I have an example of what is not clean here. Look at this mess. I don't want to work here because it's not clean. And what does it mean it's not clean? It means that I don't know what's going on. I don't know which cable to pull or which is the right one, right? So in an emergency, but probably in everyday's work, this is a mess. Yes, it's not clean, okay? While this instead is clean. And the definition I can give of clean now is the 3W, right? So you know where things are, why components are there, and what something is. Look at the picture. I feel much more relaxed in such an environment. I used to say that we engineers worship these things, but yeah, this is the definition of clean. Something where you know where things are and what happens. Okay, it's easy to understand what happens, which actors are involved. Speaking of the example that we give you today, I wrote a book about clean architectures in Python, where the example that I give you today in a very shallow way is described in all its gory details. So in the book, the example I give you today is, basically the book is around that example only. The book is freely available, so you get there, you download it. Thank you for doing it. Thank you for reading it. So feel free to go and check it out. Okay, let's discuss the architecture. What is the clean architecture? It's an approach to the design of your software that is a layered approach. So the idea is that there are at least 4 layers. There might be more, but in this example, I will give you, I use the standard 4 ones, which are entities, use cases, gateways, and external systems. And it's layered and circular. The idea is these layers are completely virtual, okay? It just means that we are writing Python code, we're writing classes, functions, modules, everything. But virtually, these classes, these modules belong to a layer. Because we decide, okay, we decide that we create something that belongs to the entities, we decide to create something that belongs to the use cases, and so on. And the idea is there are rules that components have to follow if they want to communicate with each other. Do you remember integration, organization, where components are in the layers, and integration, how components send data to each other. And the main rule, I'm going to give you an example in a concrete example in a second, but the main rule of the clean architecture, the golden rule, is talk inward with simple structures, talk outwards through interfaces. What does it mean? It means that a component in a certain layer, for example, a component in external systems, can see everything that happens in gateways, use cases, entities. In Python terms, for example, a component in external systems can instantiate a class that is defined in entities. It's known, okay? It's part of the system. So whenever a component in an external layer talks inward, it has to pass something that everybody knows. Simple structures means, for example, the structures defined by the language, dictionaries, lists, or simpler things, sets, but also things that are defined in a layer that everybody can see. Well, outwards, we have to work through interfaces. And again, I'm going to show you a concrete example in a second, but let me say this. What are interfaces? The idea of interfaces is that you don't know and you don't want to know the type of something. You don't know how something is internally. You know how it behaves. So you use something that you don't know through its methods, for example, through its interface. I'll show you in a second something more concrete. Let's discuss the example that I want to give you today. Yes, I am in time. The example I have is that of a simple, very, very simple list of objects. So think about a framework. You want to publish a web page where people can, a web page like /items, where they can see a list of items that you have in your database or something. This is the really trivial example. I wrote a book on this, so it's not that trivial probably, but I understand that it might sound trivial because in a standard framework you can create this in seconds, right? But let's see what happens behind the scenes. First of all, let me define entities. So what are entities in a clean architecture? They are simple models. In this case, as I am listing items, I have the class item written in Python. As you can see, this is a very, very simple class. It's almost just data because it has self code, self price, and that's it. It might have some methods. I didn't put them there because I wanted to keep the example simple. But the main thing I want to point out, especially if there are Flask or Django users among you, these entities are not connected with the database. This might be surprising for you because Django models, for example, they are immediately connected with the database. You inherit from model and you can save, you can retrieve the object. This is not what happens in the clean architecture. Entities are entities. They just represent something in your system. This is important for something we see later. Okay. The use case. The use case is probably the most important thing and the most important layer in the clean architecture. Because the idea of the use case is that I put there my business logic. Let me say something about the business logic. What is it? The business logic is the reason why you are in the business. So, for example, everybody can index websites. It's that easy. You just download the website, you create a dictionary of terms, you rank them. Everybody can do it nowadays, but only Google does it in that particular way. I'm not saying it's the best way. We can discuss about this. It might be good, it might be bad. I don't care now. But the problem is there is something that makes Google Google, and that is the business logic. Is that they only know how to rank and to index websites in that particular way. So whenever you create a startup, whenever you write some software, you write an open source package, whatever, you have a business logic. You have something that you know, and this is why you created that software. And this is arguably the most important thing you have. because everybody can, stream TV series. Netflix does it at the best. So that is important. And you have to take care of your use cases. This is why in the clean architecture, we isolate them as much as possible. Again, I have an example with Django. Django views many times contain almost always contain the business logic. And this is what I mean with business logic. Something that happens when someone accesses your system, when someone uses your system. In this case, I have this items list use case, which is a class. And actually in the clean architecture, use cases don't do that much. They can just be executed. Let's go on. We need, now we have the entities, we have the use cases, but after all, we want people to use the system. So we have to give them some way to access the system. And since it's 2020, many things are web applications. So we can decide to create that. It's one option, but it's the most likely option. So the web application, here I'm using Flask for simplicity's sake. I just created a root. This is very similar to what you do in Django, by the way, which is /items. And people accessing that do something. They make the system do something. In this case, nothing at the moment, because I want to go on and describe it in details. What does the web framework do? What is the task of the web framework? It is to receive HTTP requests and to convert them. So the web framework receives HTTP requests because this is what a web framework does, and has to convert that request into simple structures. What does it mean, simple structures? Here, something that the use case can understand. And the use case can see only entities and the language and Python, right? So when I pass here something, I can't pass down something that is defined in Flask, for example. The use case doesn't know it and shouldn't know it. Okay, it's not allowed because these are the rules of our little clean universe. So the web framework has to convert the HTTP request, to process it, to do everything the web framework has to do, which is an important task. But then eventually has to get the arguments of this HTTP request and pass it down. At this point, the use case has to do something. In this case, it has to show us a list of items. Where are these items? Eventually, they have to be stored somewhere, right? And this is what is called a repository in the clean architecture. Immediately, this is the example I have here, we think about a database we have nowadays. Think about it. We are not forced to use a database. We want to retrieve data that are stored somewhere. A database might be a good solution, but I didn't say, for example, a relational database. It might be a NoSQL database, but it might be an external sensor, like a physical sensor that I put somewhere, to record the temperature, for example. Or it might be a REST API. It might be a bunch of files on my systems. I'm not fast. Okay, this is most powerful things about the clean architecture. It's not opinionated. It's a double-edged sword, but it's also a great strength. So I have a database in this case, which is fine. It's probably a relational database, but as I said, it might not be. So the use case has to extract data from the database. But look at this. The use case is here, but the database is an external system. It's in an external layer. Why is it there? Because the database is something, it's what we designers call a detail. And people are so scandalized when they say the database is a detail. Because detail doesn't mean it's simple. Because I know, believe me, that databases are not simple. It's not easy to set up, Postgres, MySQL, or whatever. and to configure it, to use it. SQL is a complicated language, or MongoDB, whatever. It's a complicated part of the system. It's an important one. But it's a detail because the idea, as I said, is that I want to extract data from somewhere, what the repository is. It's okay, we have to decide it eventually, but it's not paramount. So when you search for pages in Google, you are not asking yourself, oh, wait a minute, where is Google storing this data? Is it a Postgres database? Is it MySQL? You don't care, because this is not important. It's a detail. See, it's important for the engineers in Google, obviously, but it's not important for you as a user. Okay, enough rambling about this. Let's move on. What happens? That the use case can't access the database directly, because we don't want to hard code in the use case the usage of the database. For example, this is, I don't know, Postgres. I'm using SQL Alchemy. I don't want to put SQL Alchemy code in my use case, because at that point, it becomes a use case that uses a relational database. What if I want to access MongoDB? So what I do is to create an interface, which is something that receives data from the use case and maps as an interface the most common features, the most common methods that I want to use in the database. So I'm passing, again, simple structures to the database interface, because it's something that the database interface should know. And the database interface has to convert the data I'm passing into a specific language. Here, these two are very powerful. This is a SQL query. Well, this one is not a SQL query. This one is just a method. It's a call. I'm calling a method, right? So this happens in the specific language. The database answers in the specific SQL Alchemy. So this returns a query, right? This is specific to the language. And then eventually the database interface has to return this data to the use case. In this case, we are extracting a list of items. So eventually what the database interface has to return to the use case is this list of items. I mean, this is not different from the ORM in Django, which returns models, right? Given that entities are not models, but this is similar. And this can happen because the database both can see entities. They are like looking downwards, you see, or inwards. Now the use case has the list of entities. And what shall it do? It just has to apply the business logic and return it to the web framework. In this case, I'm not applying anything because there is no business logic. I'm just extracting the list of items and returning it. But think about it. If I was, I just invented an incredibly smart way to rank items or to list them. So I am applying my business logic before I return something. It might not happen, but it happens usually. And the web framework, again, receives entities or simple structures, whatever they are. And the second thing that the web framework has to do is to get these results from the use case, this very generic result, and convert it, generic in format, I mean, and convert it into an HTTP response, because this is what the web framework does. Okay, one thing before I move on with the and concludes. What's the power of this structure? Why do we bother doing all this? We might just use Django, right? Which is, again, impressive. It's something you can use. The use cases for the clean architecture are a bit different. But the idea, one of the powerful things, there are two main things I want to mention. One is testing, and I'm going to show you in a second. And the other one is mutability. So the clean architecture can be changed easily. So let's say, for example, that I don't want a web framework. I want a mobile application, right? So I want to create something written for Android, for iOS, whatever. What shall I change in this architecture? Well, definitely have to change this part, the web framework, because it's not a web framework anymore, right? It's a mobile application. So it doesn't receive HTTP requests, but it receives something else. I don't know. I'm not a mobile programmer, but there's an interface. You're tapping on the screen. There's something happening there. But as soon as this component here receives what it has to receive from my tapping, from my phone, then it sends the very same information to the use case. And the use case has to discuss with the database interface, database again. Everything here happens the same way. So I just changed part of my system, creating a mobile application or a CLI, for example, a command line interface program. And the rest is the same. Conversely, let's see what happens if I want to move from Postgres to MongoDB. I understand that this doesn't happen many times. It's not that every day people say, "Oh yeah, we have been using Postgres, for 3 years, but now we want to move to MongoDB." It might happen. It doesn't happen every day. But what might happen is that part of your system has to work with something different. So, for example, you have everything in Postgres, but you realize that for a specific use case, for a specific logic, MongoDB is performing better. And you want to store some data in a MongoDB database. And look at this structure. You have just to replace the database interface in the database. Again, I'm not saying this is simple, but this is better than rewriting the whole thing. Okay, let me move on with the second great advantage. So let's discuss because, as I told you, the use case is the most important thing. It's the business logic. So I want it to work, despite of the I don't know about frameworks. I don't know about databases. The business logic has to work, right? Because this is what my company thrives on. So that's paramount. And thanks to the structure that I have in the clean architecture, I can isolate the use case. Because look at this. The use case receives a dictionary from something. I don't know what, from something. I can pass a dictionary during tests, right? I can just create a dictionary, pass it to the use case. It's really just a simple dictionary. And then the use case sends a dictionary to something. I said that this is a database interface, but this might be a mock object that just pretends to be a database interface, but actually just returns test data, right? Because this just has to return entities. This is test data. And the use case has to return these entities after it applied the business logic. So as you can see, I can completely detach the use case from the rest of the system and test it in isolation. This is unit testing. This is something that allows me to test the use case, the business logic in seconds, okay, while you code. There is another category of tests, which is integration tests. And these are the ones that I have to perform with the web framework and the database. So the web framework is an integration test because what I have to check is that sending HTTP requests, I get the right calls to my use cases. Okay, the fake use case receives the right dictionary, and when it sends the entities, the web framework returns the right HTTP response. This is the idea of the web framework. And the problem is I need the web framework running, so if I'm using Flask, I need Flask running. So maybe I have Docker containers, something similar. And this is what we call an integration test because it requires an external system. Remember the layer external system to be running. And this slows down the whole thing. Again, the same thing happens with with a database where I need a proper database running. I need my Postgres database running. This is what I mentioned before about entities. So why am I concerned that entities are not connected with the database? Because when you run, when you use Django, again, or Flask, when you test your business logic, your models, you need the database running, for example. This is a great limitation because you need that system up and running. Or, for example, think about this. If my source of data is an internet, an API, REST API. Okay, so I'm calling some REST API on the internet, and then I'm fetching the results and doing something. When I want to test this, I need an internet connection. And, you know, people say, oh yeah, it's 2020, we have an internet connection everywhere. Really? Not everywhere. I mean, I live in London, UK, and as soon as you get into the tube, we don't do it that much lately because of the coronavirus, but as soon as you get into the tube, you don't have an internet connection. If you have to work there, okay, right, you can read a book. But my point is, you are depending on an external system. That is not the main thing when you test the business logic. It's the main thing when you test the integration, okay? So this is integration tests, they require an external system. You can isolate them from the business logic as well. Okay, to conclude, 2 questions. Is it possible to migrate an existing system to the clean architecture? So I have a system written with Django or Flask or any other framework, and I want to migrate it, you know. And it's always possible. It's always possible to use something new. And this is probably the answer to this is it's a bit generic, but it's an advice for you friends about design. Never, never, never replace the whole thing at the same, in a single go. Never. Many people try to do it in the computer science history, and they mostly failed. So my advice is, for web applications, for example, think about using load balancers and routing parts of your system to something else. So if you have the bulk of your application written in Django and you want to try something written with the clean architecture, you might say just this URL goes there with the load balance. Okay, so this is the most general advice I can tell you. The same if you have a clean architecture, you want to implement something written in a smaller framework or something simpler, right? You can do this. So, but yeah, keep this in mind. Never try. Okay, if I convince you, I don't know if I did it, but if I convince you that the clean architecture is the future, don't go and replace everything in one go. Don't do it. Don't say I told you to do it. Okay, I don't want the responsibility. The other question I have is clean architecture the definitive architecture? Is that the best thing ever? Hardly. Okay, no. So, no, I believe there is no such a thing, because this might be, I told my friends at the Django meetup, this is the answer to every single, or probably 99% of the questions in computer science. It depends. It depends on the requirements. It depends on what you want to do. It depends on how much time you have to spend on the system. A clean architecture is complicated. It requires a lot of work. You have basically to write everything from scratch. But obviously, hit your screen in Django, you just fire it up, you write a couple of things and everything works. Great, amazing. It depends on what you want to do. It depends on your requirements and your future requirements. Okay, so think about it. As I said, I wrote a book on this, so I greatly appreciate if you go and download it. It's free. If you want to donate, I'm not going to complain, but it's free. It has been downloaded by 13,000 people so far, so I believe there is something good in it, and I'm proud of it. There is another book that my friend Harry Percival, together with his boss, Bob Gregory, wrote recently. It's Architecture Patterns with Python. It's published by O'Reilly. It's freely available in online because O'Reilly kindly agreed on this. You can find it at cosmicpython.com. And that's it for today. I made it in 40 minutes, which leaves a lot of time to you for networking or for questions if you have. Thank you. Okay, so let me read questions on the chat. Combine complex multi-stage interaction with a user, single user case. How would you reflect that in the clean architecture? Break into small. Okay, yes, Rob, interesting question. So Rob is asking, when we are modeling a complex interaction with a user as a single use case, how would you reflect that in the clean architecture? Break it into multiple small use cases? Yes, generally speaking, you tend to try and break things. There is an interesting thing to say here, that there is a philosophy, among programmers that methods should be very, very small, and objects should be very small as possible. It's interesting to discuss what as small as possible means, because again, it depends. You see, this is it's for real. It's the answer to every question. It's like 42. It depends on what your use case is. So the point is, you should try. This is what you have to keep in mind. You should try not to do too many different things in your use case. So, for example, if you are logging in someone in a system, that's the point. Log in. Then you might want to show something in the dashboard, for example, or to perform other security checks. This is something different. So yes, if you can decompose your use case into simpler things, but then, this is a very generic answer. So we should discuss a concrete example. I'm available if you want to discuss, but yeah, this is my hunch about it. Okay, so another question, Daniele, a provocative question. If we never do it at once, where is the best place to start, especially if we are new to this and not quite sure where we are going with it? Okay, great. So, interesting. I would say one of the best things that people find in frameworks, let's say, for example, Django, is that it provides out of the box many things like, the login, the management of users, all these things that are actually they're not complicated, but they might not be trivial for newcomers. So I would say probably the best place to start is an internal business logic. So, for example, let's say I'm giving you, generic examples now, but let's say you have a booking system, for a conference, and at a certain point you want to show the schedule of one day of the conference. You want to show people the tickets they have. Those are nice, very little self-contained use cases. You have to show something. You have to list something. It's really self-contained. This is what I mean. It doesn't interact that much with the rest of the life of a web framework user. I don't know, Daniele, if this answers your question, but this is where I would start. Also because, these are the places where the problems are. So what I mean is, first of all, you are not forced to use the clean architecture. Okay, if you are using the framework and everything works for you, why should you change? So don't do it. The point is, I saw many systems where people are struggling. So, for example, you implemented something with Django, with Flask, or with any other system, and you find a specific query, a specific page to be extremely slow, or maybe the ORM doesn't exactly do what you want, and you think, oh, if I could use my MongoDB, which is much better than Postgres, I don't Postgres is amazing, but MongoDB is different. So it has use cases. Okay, so that is your point, where you can say, okay, why don't I start there and detach that part, that specific URL from my system, and maybe implement it with something different. Microservices are very similar to the clean architecture, because in the end, you are saying that you have a big system and you start thinking, okay, don't convert everything into microservices at the same time in one go. Implement one single thing and route your request there. Yeah, that's it. We don't have other questions. Oh yeah, yes, we have. Does OOP or design patterns augment the clean architecture? Okay, I think you can implement a clean architecture in whatever language you want. Okay, so that's not directly connected with OOP. I gave you an example in Python, so I obviously used object-oriented programming. You can implement that in functional programming language, definitely. So I wouldn't say they are directly connected. It's interesting, though, so thank you, Joseph, for your question, because I gave a workshop on object-oriented on Wednesday, which is available online, by the way. And one thing I mentioned is that object-oriented was invented by people who who wanted to replicate a computer system into a program. So they wanted to have small computer systems interacting with each other. These are the objects. Does it ring a bell? That's microservices, right? So you see, computer science is just like discovering over and over the very same things, the very same concepts. So I would say that it's interesting that object-oriented can be a clean architecture. Inside an object-oriented system, you can start thinking clean and thinking what the responsibilities of objects and the relationship between them. But in the first place, I wouldn't say that object-oriented is directly connected with the clean architecture. They are somehow independent. Okay, and this is the point. Sorry, and then I stop maybe rambling, but this is the point of the clean architecture. I don't know. Well, I might know, but I don't need to know how something is implemented internally. So how is the framework implemented? I don't know. How is the database implemented? I don't know. Think about this, just to give you a final idea of why this discussion about architectures is important. When you go and visit a website, right? For example, Google, right? Or you use AWS maybe. Do you know how Google is implemented? I don't. I mean, I don't know. Well, how is it implemented? There are people knowing this, maybe among you. But I personally don't know. And this doesn't, stop me from using Google every day. Because what I want to use is the interface. So again, you see, we are living in a world where we keep interacting with interfaces and using them and trying to detach ourselves. We don't want to know how Google is implemented because we don't need to couple our system with the internal system of Google. There is a REST API, whatever. That's our connection. And this is the maximum coupling that we want to establish. Okay, so this is about it. I hope I answered the question, Joseph. I believe that's it. I don't see other questions. As I said, I'm available. I'm reachable online on Twitter. Download the book. Visit my website. I'm really. I made myself a point of answering whoever gets in touch with me. So if you drop me a message, if you have questions or anything, feel free to ask. And thank you. Thank you for being here. Thank you for your patience. 50 minutes. Wow. Thank you.